Hey everyone! This video is going to be over missing data, which is the second step in data screening. I have already recorded the first step in data screening, which is accuracy. So if you are having problems with that, you can go to my first video. And that video will also mention why data screening is important and some of the rules we follow for data screening. But like I said, this video will just be over missing data. I have also provided a PowerPoint so you can follow along and make any personal notes if you wish. So the study is still the same as the first video, and I will just briefly go over what the study is about, so people who haven't watched the accuracy video can listen to this and not be lost. So for this video, I am using some fake data, and in this fake study, we were looking to see if stress and anxiety predicted memory. So participants took an anxiety test to assess their respective anxiety disposition. Then participants were given 5 minutes to read 3 scenarios. Next, participants took a memory test. And after the memory test, they rated how stressful the memory test was. So for this fake study, the independent variables were gender, which is our categorical variable, anxiety, which is a continuous variable, and stress, which is a continuous variable. And the dependent variable was memory, which is also continuous. Now, if you are confused with the IVs being continuous or anything about this data, don't panic. If you are running a t-test, an ANOVA, or whatever you're running, these basic rules and steps for data screening are still the same, with a few exceptions. So really just focus on, if you are understanding the steps in data screening, don't focus too much on the study because you may not have gone over having more than one IV or if your IVs are continuous. But in general, data screening for the most part has the same basic steps and rules for all analyses with a few exceptions, but we will get to those in later videos. So I am going to go to my output. Now, once you have fixed the accuracy issues, you see that you have missing data in the statistics box, so this box right here. You see that you have missing data where it says missing. And we see that for gender, we have 0 missing data points. For anxiety, we have 4 missing data points. For the stress column, we have 2 missing data points. And for the memory column, we have 1 missing data point. Now let me get to my missing data slides really fast. With missing data, there are 2 things to be concerned about, and that is MCAR or MNAR. MCAR is where people are missing data completely at random, which is what you want if you have missing data. This was probably caused by accidentally skipping a question or missing a trial. However, with MNAR, that is missing not at random. So participants are missing on purpose or for a reason. And it also may be the question that's causing a problem. So for example, what if several people skip questions about smoking? Well, maybe when you look at the question, you asked if they smoked or not. Then your following question was how often they smoked. And in that question, you didn't give an option to say that they didn't smoke. So people who didn't smoke just skipped that question. So you may want to delete that question altogether. Now, you want to replace data that is missing completely at random, but you do not want to replace people who are missing not at random because then you are just making up their data when they purposely left it blank. So in data view, you can check if MCAR or MNAR is missing not at random or completely at random by right-clicking on a variable or a column in SPSS. And I would right-click and sort ascending. And if that doesn't work for some reason, you can also go to Data, Sort Cases, and move the variable you want to sort over. And you can only move one variable over at a time. So we're going to click Anxiety, hit Ascending, and hit OK. This will show you if you have missing data at random or not at random. If it is not at random, then you see that the participant just stopped because the rest of their row will be missing. So If a participant just stopped, then a lot of their row would be missing. And we only have 4 columns, so it's kind of hard to tell. But in data where there's a lot more columns, it would be easier to tell if they just stopped and left a lot of their row missing. Also, if a variable is a problem, then you will see that most of the data in the column is missing. So if anxiety was a problem, then we would look in this column and see that a lot of the data would be missing. Now, obviously, that's not the case in our example, but that's just what you would look for. However, if the data is missing completely at random, then you will see blank spots just in random places. Now for this variable, they're not in random places because I sorted them ascending. But like in stress, that also was sorted with anxiety because these two matched up. But like if I scroll down, I see that, oh, memory has a random spot. So that was random, that wasn't on purpose. Now, there is also other data that you can't replace besides MNAR, and that would be categorical data, so things like gender. You also don't want to replace demographic data, so things like race, age, weight, basically anything that is personal to them, because you don't want to guess what their race is or what their age is. So most of the data that is replaced is continuous variables, so interval and or ratio. Okay, so once you decide if it is MCAR or MNAR, then you have to decide if your missing data is at 5% or less. The 5% rule applies across, so which is by participant, so how much data is the participant missing, and down, so by variable or column, so how much of that variable is missing. So going down, I see that we have 97 rows in each column. So I would times 97 times 5%, which is 0.05, and I get 4.85. So that means that I can have about 5 missing pieces of data and still fill it in safely. Now that was just for going down. Now for rows, so by participant, we have 4 columns. We have gender, anxiety, stress, and memory. So I'm going to 4 times 5%, so 0.05. That gives me 0.2. Now, you wouldn't replace any data points in gender, but you still use the gender column to see what 5% would be, what 5% or less would be. So if a participant has more than 0.2 missing data points going across, then you can put them in the not random group, so meaning don't fill this in. But if the participant has less than 0.2 missing data points, and the column that they're missing in also has less than 5 missing data points, then you can fill it in. So let's just say, for example, that this person is missing less than 0.2 data points, and in that column that they're missing in also has less than 5 missing data points, then you can safely fill that in. Now, it is kind of impossible for someone to be missing 0.2 of a data point. Most data has more than just 4 columns that participants have filled data in for. So when someone is missing data, they might only be missing at 2% when looking across because they have a lot of columns. So for example, instead of me only having 4 columns, let's say I have 40 columns. So 40 times 0.05 gives me 2. So if the data had 97 participants in each column, like ours does, and 40 columns that the participant has data for, so 40 columns instead of just 4, then if someone who is missing 2 data points, and in that same column, that column has less than 5 data points, then we could safely fill it in. So if this person, let's just say we have 40 columns and this person is missing this one right here. And in this column total only has less than 5. So it'd be this one right here and 1 and 2. So 3 total. So because this person is missing only one data point, and in the column that they're missing in is less than 5, then we could fill this one in. Now, once you decide what participants are missing at 5% or less, and what columns are missing at 5% or less, then I would suggest splitting up your data into 2 different data sets. So one data set would be the stuff that you can't replace, so that would be stuff like MNAR, missing not at random, and then just your participants who are missing more than 5%. Now, I would still keep the columns if they are missing more than 5% and missing at random in the data set of things that you can replace. Because, for example, the column may be missing at only 6%. Let's just say, for example, that the column is missing at only 6%. So you wouldn't want to delete that whole variable because that is only missing more than what you can replace. That doesn't mean there is a problem with your variable. So unless you can tell that the column is missing not at random, then I would still leave them in your data set of things that you can replace. And I will tell you what you can do with the columns when I get to that part. So when you split the data sets up into 2 different data sets, you kind of have 2 options. So you can only work with data that you can replace, or you can work with both. So the things that you can replace and missing data that you can't replace. And only working with the stuff you can replace would be excluding people list-wise. When you exclude people list-wise, that means you are excluding them for all your analyses altogether. So you leave them out, don't look at any of their data. Now, when you look at both, so data that you can replace and data that you can't replace, then that would be excluding people pairwise, which means you only exclude participants when they have missing values for that analysis. So if you had a study that you wanted to exclude pairwise, you split them into 2 different data sets, like I mentioned before. So one data set with things you can't replace, and one data set with things you can replace. And you would go ahead and replace the data that you can, then recombine your 2 data sets. So copy one data set and paste it into another data set. Now, in my personal opinion, I would go with listwise. And not just because it seems easier, but also if a person is missing a lot of their data, then it won't be a huge benefit for me to keep them in. And if a column or variable is missing a lot of data, then that could mean that there might be something wrong with that variable. So I probably wouldn't want to keep that in my data for analyses anyway. So I would just split up your data into stuff that you can't replace and stuff that you can replace, just because of the reasons that I discussed earlier. So back to this example in our data. I'm going to minimize this. We only have 4 columns: gender, anxiety, stress, and memory. So if someone is missing one data point at all, then they are already missing at 25% when you're looking across. But I'm going to go ahead and fill in the data that is missing more than 5% to show you what you would do. But just know in a real situation, you would not replace if the missing data is more than 5% when looking across and down. Now, to fill the data, you would go to Transform, Replace Missing Values. Now, the very first thing that you want to do before anything else is under Series Mean, click Linear Trend at Point, which is it right here. And linear trend at point is somewhere between a regression analysis and a mean substitution. So it replaces data based on the row average and the column average together. So basically that's the grand mean for the row average and the grand mean for the column average. Now grand mean is just the average of the averages. So it's the average of all the column averages, and it's the average of all the row averages. Now I know that not all of my variables have missing data, but I'm going to go ahead and highlight everything because the places that are missing are the values that are going to be filled in. So even though I am highlighting gender, there are no places that SPSS can fill in. So it is fine to highlight. Now, if you split your data into two different data sets, so this was the thing that I was talking about earlier that I said I would come back to. So if you split your data into two different data sets and leave the variables who are still missing more than 5%, but still missing at random in the data set of things that you could replace, then you just wouldn't move them over to the right. So for example, if we have missing data in our gender column, which is right here, then we wouldn't move it over to the right. So the missing data, you wouldn't move it over to the right, so in this box of things to be replaced. So if you had another variable besides gender that was missing more than 5%, but still missing completely at random, then you can still leave them in your data set of things you can replace. Just don't move that variable over to this box for SPSS to fill in. And you still want to leave those variables in there because they are still valuable. So like I said earlier, even if a variable is missing at 6%, that doesn't mean there's a problem with your variable. That just means that that's over the amount of things that you can replace. So if you were excluding people list-wise, this is one way to keep those variables still in your data without them getting replaced. And really, splitting up your data into two different data sets is really to make sure you exclude participants who are missing too much data and variables who are missing not at random. And just a reminder, in this example, some people will be missing at 25% or more, but this video is just to show you how to replace missing data. But in a real situation, you would only replace 5% or less when looking down and across. So I just wanted to remind you of that. Now I'm going to go ahead and highlight all my variables and move them over. And I am going to go ahead and hit OK. And this creates me a bunch of new columns. And the new columns are the ones that have an underscore and a 1 at the end. And I could just check and see how many data points got filled in. So for anxiety, I see that 4 data points got filled in. For the stress column, I see that 2 data points got filled in. And for the memory column, I see that 1 data point got filled in. So what happened was it created new variables that are missing replaced. So now what I can do is delete all the variables that I had before, and that will give me a data set of only the variables where I have replaced their missing data. But before I delete anything, I am going to save this as a new data set. Just in case I mess up on anything, I have the original data set to go back to. So I'm going to save this as no missing data. I'm going to hit save. And I would recommend that after each step, just because if you do mess up, you can always go back to the last step that you were working on, so you don't have to start the whole process over again. Now I suggested deleting the variables that you had before because it is very easy to accidentally use the wrong variables in other steps. So it's very easy to use these variables over here instead of these new variables that you want. So to delete them, I can highlight them, click Edit, and then click Clear. And now I see that I only have my new variables. And if you don't like the underscore and the 1 at the end, you can just double click on this and then just rename it. So now you have gender instead of having the underscore and the 1. And this is it for the missing data section in the data screening video. And my next video will be on outliers.